In this video, we're going to look at how to shift an exponential function to the left, to the right, or up and down. And if you'll think back to when we discussed translations of the absolute value function, what you see here in terms of the equation should look very familiar. So all we've done is we've taken our typical exponential equation of a times b raised to the x, and I've added these two parts in red or blue. So to the x, I've subtracted some value called h, and I've added some number k to the end. Now whatever these numbers are will shift the graph of my exponential function to the left or right, depending on h, and up or down, depending on k. So I've set up an exponential function where both a and b are 2. So my initial value is 2 and my growth factor is 2. Every time I go over by 1, I'm multiplying the y value by 2. And what I'm going to see now is that if I use these sliders to change the value of h and k, that it's just going to move this graph around. Now, if you're not paying attention to a certain point, it may look like other features of this graph are shifting, but if you focus on the initial value, which I have made a nice point on for us to focus on, what you'll see is that when I change the value of h, I'm really just shifting this function to the left or right. So let's do that. I'm going to take h, and I'm just going to move this slider around, which will change the value of h in the equation, and watch what happens to our y-intercept. So when I slide it around, all that does is shift the entire function to the left or to the right. Now, if I do the same thing with k, that is going to shift the value of this function up or down. And so notice that the only thing that is changing is I'm picking up the whole graph and moving it either up or down. When h and k are 0, it's like these don't happen, and I'm left with my normal a times b to the x. But anytime I have these two, I'm just shifting the graph to the left or to the right. Now, interestingly, just as with the absolute value functions, h is going to be backwards of what we think it is. For instance, if I have the equation y equals a times b raised to the x minus 3, even though we're looking at a minus 3, that is going to be shifting the graph in the positive direction. So if I'm just looking at the equation, minus some value of h will shift the function to the right, plus some value of h will shift it to the left, which is sort of opposite of our expectations. K, however, behaves just like we would normally expect. If I add 1, it shifts the function up 1. If I subtract 2, it shifts it down 2, etc. So just as with our absolute value functions, the h in the equation sort of operates backwards of what we would expect because it's x minus h, and the k operates just as we would expect with plus k. So again, if I have an equation that looks like, for instance, y equals a times b raised to the x minus 2, that minus 2 would shift the initial value 2 places to the right, and then plus, let's say, 1 for k, that would shift that initial value up by 1. And so now we would have the seemingly new exponential function. Notice that when I changed k, it changed the asymptote as well. This is how we can get exponential functions where the asymptote is not at 0.